So what about non-square matrices? I didn't talk about inverses of non-square matrices. There's a good reason for that. To see what I mean, let's take a look at this question here. Is there a 2 by 3 matrix A and a 3 by 2 matrix A prime such that A times A prime is the 2 by 2 identity matrix and A prime times A is the 3 by 3 identity matrix? There's no problem getting A times A prime equal to the 2 by 2 identity matrix. For instance, if A equals 1, 0, 0, 0, 1, 0, and A prime equals 1, 0, 0, 1, 0, 0, then A times A prime is going to be 1, 0, 0, 1, which is the 2 by 2 identity matrix. However, what about getting A prime times A equals I3? In this case, with this example here, that doesn't work. You're going to see, if you try that multiplication, you won't get the 3 by 3 identity matrix. But I can show you why this doesn't work even in general. So let's consider the homogeneous system. AX equals 0, 0. The rank of the matrix A is less than or equal to 2 because there are 2 rows, because A has 2 rows, which is less than 3, which equals the number of variables in the system. So the system has infinitely many solutions. So there are infinitely many solutions to the system AX equals 0, 0. Okay, well, how's that going to help us? Well, notice that AX equals 0, if that's true, if we have one such solution, well, that means that A prime times AX equals A prime times 0. I just multiplied both sides on the left by A prime, which means that if A prime A were equal to I3 for some A prime, we would get I3 times X equal to the 0, which would mean X has to be equal to 0. So in other words, if I have some matrix A prime for which this is true, then the system here would have to have infinitely many solutions. But if it has infinitely many solutions, one of those solutions is not 0. But what I just argued about over here tells me that that non-zero solution that I chose actually had to be 0, which means that our initial assumption that we could find an A prime for which A prime A is I3 has to be false. More generally, unless A is square, you can't find a matrix A prime for which both A times A prime equals the identity matrix and A prime times A is the identity matrix. That's why when I talk about invertible matrices, I only talk about square matrices.